Right, let's continue very quick. Okay, I go over the machine learning again. Now, the machine learning, we have three categories. We have supervised machine learning, we have unsupervised machine learning, then we have reinforcement machine learning. Now, supervised machine learning. This type of machine learning or this category of machine learning deals with a situation whereby involvement of you, the scientist, or you, the AI expert, is required. For example, you want the machine or the system you are building to actually classify some things under some categories. We are using flowers. Now, here lies the case. You have three different groups of flowers you want to label them with. So we will say label one, label two, label three. Right. After that, we will actually give various properties to these labels. So we will tell the machine, look, we are giving you this data set, and this data set is particularly for label one. Now, see, in label one, when the person shows you the flower, and the flower has a green color and smells like an orange, place that flower under label one. Okay, when the person shows you a different flower with color green with these characteristics, place that flower under label B or 2. Now label 3 requires a flower with let me say a violet color with this specified characteristics. Place that flower under label 3 or label C. Now, here you will see that you, the AI expert or the scientist, have actually given a label to the machine to follow. The machine is not automatically labeling them, no. You have given them the label it should follow. And so the only work the machine here is going to do is going to compare the characteristics of each flower and assign them the label you have defined. This is the term supervised machine learning. The main thing here is it involves you, the personal, your involvement in the labeling. Any question, please?
Hello, sir. So mine is a question per se. So we could use, let me say, in the hospitals, they made mention of they have diseases and drugs that
Okay, go ahead.
they prescribe for each. Let me say, what's the name, bitten by mosquitoes are having malaria and different animals. So that means you determine the categories as a result of, let me
Uh,
say, the infection the person is having. So if it's malaria, then it's this. If this, then that. Is it really the case?
okay. Now note that hospital system on or app. It depends you, the developer, or you, the scientist, who is going to build such thing. It's either you want to build it in a way that will take in a form of supervised learning or unsupervised learning. That same system, someone might decide to build it in an unsupervised learning, whereby the machine will do everything from scratch. But someone too will prefer supervised learning, whereby he or she will define everything. Please do get it. It depends on your preference.
Okay, please.
Okay. If there are no questions, we are moving on. Okay. Now, in supervised learning, please take note of some key points here. We have different supervised learning algorithm. Now note, I taught you guys algorithm. Okay, for the sake of the newbies, let me quickly run you through what an algorithm is, because in artificial intelligence, it's basically algorithm you are going to use. Now, the term algorithm, this term I've underlined. Oh, let me make it. Yes, I've made it yellow there. Algorithm. Now, algorithm, it is the step by step way of solving a problem. Full stop. Algorithm, it is the step by step way of solving a problem. Full stop. I go over again. An algorithm, it is the step by step way of you, the scientist, or you, the AI expert, solving your problem or creating that your machine or the software. Okay, I showed. Let me show you some example. I like illustrating so that you can actually understand things. Let me give an example of an algorithm so that you can know what we are talking about before we move on. Okay, let's use this algorithm. Oh, better still. I want a payment transaction algorithm. How payments are being made whenever you make a payment. That will be the most simplified method for you to understand algorithm before, because if you don't understand algorithm, learning AI is just like carrying water in a let me see uh, let me, okay, I've gotten one. Credit card payment. Okay, let's use this one. I think this one will do. Now I'll share it on my screen for you to see it. Okay, so I assume everyone can see my screen. This is an no. Can you see the lines actually drawn inside between the boxes, please? Can you see the line? There's an arrow drawn inside. Can you see them?
Yes.
Okay.
Yes, sir. Yes, sir.
Okay, let's move on. Now, This is an algorithm. You need to understand this before you even try to build a system. The first thing you need to do. Okay, this is an algorithm for credit card processing. So whenever you use your credit card online to buy something or to pay for something, yes, this is how it goes through. Algorithm is the step-by-step way of doing things or solving a problem. Now, or say order placed with credit card as payment method selected. So the payment method you've actually done your shopping, everything, you proceed to payment, then you selected credit card. So everything starts from this particular thing, credit card. Let's move on. Now transaction started in other system. You've activated transaction. Then this activation here means now you are actually entering your card number on the site, card number and your three digits number. After entering and you click on pay, this is the process it goes through. Now, it's going to verify by Visa. If you are using a Visa, your information is going to be sent to Visa for Visa to see if the card actually belongs to them, is for them, or they are the certificate guiding that card is Visa as it is written on it. Then Visa will say, okay, yes, it is our card. Then the card proceed. The process proceed from there. So it's a step by step. Okay. Now it comes here, a question again. Is the credit card valid? The credit card the person is using to pay, is it valid? Now here we are going to your bank. Here we went to Visa. Here we are going to your bank. Then we ask your bank, please bank, this bank, is this credit card valid? Then the bank will say, the bank will check the expiry dates, the date issued, and compares it with what the bank has in its database. And the bank will say, yes, it is valid, or no, it is not valid. If your bank says no, card is not valid, you see you will pass, your card will pass here, meaning customer must enter new payment method. It means that card is rejected, and so you can't use for payment. You have to choose a different method for that. Okay. Now, in a case whereby the banks approve that the card is valid, proceed. Now you come to another question. Is the funds available on the card, is it enough, or are there even funds on that card that can be able to actually process the amounts you've actually purchased? If it says no, look here very carefully. If it says no, the funds available are not enough, or you have no funds available in that account, you will go back to this particular thing. It says customer must enter new payment method. But in a case you are saying, okay, the person has enough money in the account, let the person go through. Then you proceed. Comes here. Transaction will be made completed. Then a receipt will be sent either via, some uses SMS, some uses email. You receive a receipt. Then this transaction is reflected in the customer's database as information with the bank. So the bank, so you can see when you make a transaction, you go to you request for your bank statement or something, you can see all the transaction made. It will be stored here automatically. Then transaction is also entered in their ledger book. Then entries are reconciled at the end of the month. These are for the banks. So you see, it was a step by step before that transaction you made online went through. You don't just enter your card and you just deduct. No, this is the process it goes through before you can buy something online. So whoever here who has purchased something online before using a credit card, this is what you went through. But it happens within a matter of some seconds or few minutes. You won't see. All what you see is payment successful, then maybe you will get your receipt. This is the process it goes through. Okay. So this is a pure or a typical example of what algorithm is. It is the step by step way of solving a problem or the step by step way of completing a particular task. Please, any question before we go back to our. Okay. If there are no questions, let's continue. Now, I assumed, or I can boldly say, everyone in this class has understood what an algorithm is. Now, there are different types of algorithm used under supervised learning, supervised machine learning. These classification models include logistic regression, we have decision tree, we have random forest, we have gradient boosted
Boosted
tree.
through multi-layer perceptron, one versus rest, naive based.
Okay, thank you, Rafaela. Okay, let's move on. Now, regression. This means continuous value over time, and regression is specialized for forecasting values based on features from previous values over time to predict the mean value in future. Right. Now, let me break down so that you can understand this. You are living in a particular city. So let's say you are living in Accra. Then you can see in Accra every Monday. It's an example, please. In Accra, you are where you are living. Every Monday there's heavy traffic. Meaning, if you would have to go to work on Monday, you would have to wake up early. If you have your own car, set up early. If you don't have your own car, you have to actually go to the roadside or order your boat or Uber early, then set off. Because if you delay, you arrive at work very late. This is what you've seen. You as individual, you've seen. Okay. Now, a company comes to you to employ you that you as a scientist or as an artificial intelligence expert, we want you to design a model for us or build a model whereby we can actually we are a company that can offer services to people that can actually help people find the shortest possible route or the less busiest possible route to our work, so that should there be a case whereby the person one way or the other faces some circumstance and couldn't start early the day with the day, like to set up around 9, and you see 9 the person is doomed. The person will get a chance to arrive work very early without taking the normal route. You as AI expert do it for us. Now you will sit down using this regression method. You are going to actually train your machine with previous data of this particular road or this particular city. So you take a week. So let me say 2 3 weeks to study it. So week one, you realize Monday to Friday, from the time maybe 6 of let me say it's 8 to 10:30, the major road from maybe your where you are staying to, okay, let's take an example. The major road from let me say Adenta to let me say Accra Central, that major road, it's very busy and stacked with traffic and a whole lot. So if you are driving or if you pick a car around that time, you are doomed. That's what you saw from Monday to Friday, week one. Now, week two, you saw the same thing. Week three, the same thing. Week four, the same thing. You go to your machine, then you give it to your machine. Then your machine process the data and your machine will draw patterns and realize, oh, okay, so from Monday to Friday, specifically from you are starting from Adenta to Accra Central using that major road, you are going to be stuck in traffic for about an hour. Okay. Then within those 4 weeks you did your research, you also try to find route connecting to this major route. So should someone be in this major route, let me say the person is in this major route but has reached Shiashi or airport. Now you found out with your research, found out that there is some short road the person can take and actually arrive at 37. Okay, then you pick this data too, you give it to your machine. Now here your machine has also realized, okay, we have different roads when the person is specifically on the major road at Shiashi. The person can pass here and pass here, pass there, and let me say in within about 15 minutes, the person can get to 37 without taking the main route. Okay, you've given that data too. Again, you also realize in this your 4 weeks of research, you also got a data that should the person be in the traffic, then when the person got to Shiashi, he or she was making a call back. So um within a twinkle of an eye, he or she passed by Shiashi. If the person is at airport, there's this short road the person can take, and it will take the person straight to in front of Flagstaff House so that it can get to that lane. Oh, okay. Then you add that data. Now, in this 4 weeks again, you realize maybe the person bypassed airport, Shashi. Then the person is at, let me say, 37. Now, and the traffic is very jammed. There is this short road the person can take and arrive at this Independence Avenue heading towards Ridge. You've gotten that data, you've given to your machine. Very fine. Now, your machine is going to get this data, process it, draw patterns in it, and based on this, your machine will be able to predict and give solutions to the company. So you use this model, build a system for that company. Now, you see, the company will come and boast to the customers. If you used our app or use our system and you are in a traffic and your location is in Shiashi, our system can direct you in a route using 15 minutes, you can get to 37. So the customer will be, oh wow, that's cool, that's cool. So they will download that app or purchase that app in their various vehicles. Then they get the customer Monday to Friday. The customer, let me say on Wednesday, the customer within that same period, 9 to 10, the customer was in traffic, then gets to Shiashi, then remembers the app, opens the app, then it starts showing the customer the route. Within 15 minutes, the person gets to 37. You see, the machine has been able, you've been able to build a model or a system that can predict. So here it is algorithmically intelligent. It has used the data you've provided to intelligently create a channels to help people to actually go on with their daily life. So the ability for you to create a model based on features or previous values or previous data modeling to predict the future. So maybe the person is not quite familiar with Accra. The person just moved to Accra, so the person has purchased this app. Now the app is going. Now let's say it's Sunday evening. The person will go to work on Monday. The person will open your app, then go through. Then your app will tell the person, look, you are in Accra now. Listen, if you are within this route and you know you are going to pass this major route from Adenta to Accra, don't set off 9. Set off before 9. And should you set off 9 and you get to Shiashi, pass here, you will use 15 minutes to get here. And if you get to 37 and the road is still pass here, you use 15 minutes to get to Independence Avenue. Pass here, you will reach your destination. So it would make calculation and be like, okay, so if you use our routes, our this simple route, you are just going to use 30 minutes to reach your workplace. So it will give this information or this future event or future prediction to this customer, and the customer will like the system or the model, and it will help the company to excel in whatever way it wants to advertise itself. Any question?
No, please.
Yes, I'm listening.
So please, with all your data that you have in with regards to the particular illustration you use, there are unforeseen contingencies and problems that could occur. So if it disrupts that particular locations you have given, assuming that, let's say, going to moving from Legon campus to the Flagstaff house, and the very route that you assigned, fortunately and unfortunately, there is a construction that is to take place on the major part of the road that will limit what that particular information you are giving to your device or the data you have provided to help the direction. So in that case, you didn't take into consideration that, and if that happens, won't it disrupt the whole system that you are trying to build, and actually if have negative implication?
Okay, very good question. Now, the developer or you, the scientist, you give an error of margin, whatever system you are going to build. And machines, they can't act for themselves. You have to provide information. Note the machine is going to follow whatever data you provided. Now, your question: in a case whereby you gave your machine that short route, then the driver decide to take that short route, then gets to maybe in the middle of that short route there is construction, so saying all cars must turn or all cars must use the major road. Yes, here there is a disruption in your services, but the fault is not your fault. It is, let me say, so it's something beyond what you can control. So let, for example, you've built your model and your machines are predicted to customers say, okay, when you get Shiashi and there is a heavy traffic, use this route. Now the person decides to use that route, and unfortunately, while the person is going on that route, there is an accident which has occurred, let me say, about 5 minutes ago. That incident, you can't control it because you can't control accidents. So maybe there's an accident which actually involves or which actually prevents any car from using that route at that moment. That would be an unfortunate for that customer. And the customer can't blame you for that because that one, it's let me say our daily life and it can occur. So as I said, we have margin of errors. Your services can be perfect. There definitely there might be let me say there might be also See here, now the person gets to Shiashi. You are saying he should take that route, that short route. Why did the person took that short route? Then all people using your customers are on that short, causing traffic on that short route more heavier than the main road. Meanwhile, the person has gotten to the middle of that also short route. You see, so whatever system you are building is not perfect. There will be some circumstances you will encounter problem that's beyond you. It's humans you are going to deal with, and there are some circumstances you face such problems. When such problems comes, it's not your fault. You build your perfect system. You build a system that's close to perfect, but not perfect. There might be some one way or the other you might encounter such problems. You can't control such problems. Are you cool?
Yes, please, I'm fine now.
Okay. Please, any question before we move on? Now, the next example I'll use is weather forecasting. Weather forecasting. Now, you see, it will also use the same algorithm. This is whereby the model you are building or the model you build for that company or for your company or the system you are building is able to gather data for a particular climate. Then based on that, it is able to predict tomorrow, tomorrow's weather, let me say, changes. So meaning all weather forecasting apps used previous data that has been gathered or accumulated to predict tomorrow or to predict the future. So it says now for about 5 years, this is what the model you gave to your machine. For about 5 years, so let's say from let me say 2017. Okay, from 2017 to 2022, you have determined that every June of each year there is heavy rain in the city of Accra. And that rain actually occurs on the 25th or the 5th or the 15th of June. Now, you can also gather that information to the extent that now you see you say now whenever this day comes and the rain falls, there is flooding. And this flooding carries this volume of water. And the flood takes this route. Now, this is the data you are building, the data you are given, the analysis you are given. So you will give all this information, all this data to your model, to your machine, or to your software. That's you are training with that data. Now, after training, you will see your machine will boldly, or your data, your software can be boldly predict June 2023, on the 15th of June 2023, this is what going to happen. There is going to be a heavy rainfall. And when this rain occurs, there is going to be flooding. And the probability that this volume of water is going to flood through this city, through this channel, and going to cause this damage. Now, it can be able to predict at even the time it's going to rain and the duration the flood is going to take. Now you've built your model, you've trained your data, you sell it to the company, or if you want to also use in your own company, people will start purchasing. Now you see, when it's getting to June 2023, your app or your system will start prompting the users. Are you staying in this city or this area, on this day don't go out, on this day move from here, on this day don't come here. Why? It will be giving this all these calculations. Then this day will come, and truly, truly, there will be rainfall, there will be flooding, people's things will destroy, people's this will get over this will turn upside down. Now, how do you think in the Western world currently there was this hurricane in Florida, Hurricane Ian, okay, in Florida. Now, when the hurricane was about to hit Florida, the south, I think southwest part of Florida, it was about to hit. They were able to determine this day, this particular time, Hurricane Ian is coming to hit. And so this is the damage is going to cause this. And they were able to predict it is a category 3 storm. And in category 3 storm, during the process, is going to transform to category 4 storm. Now, this is the route, or this is where the hurricane is going to pass. So you see, it's because of the previous data they've gathered and they've trained the model with. The model was able to predict and tell the residents there to leave. So if you're a resident there and you didn't live on that particular day, you will see it's the exact same time Hurricane Ian will come, then will take you away. Or was predicted based on this model or based on the data that has been fed on previous occasions. Any question?